Okay, so now we're continuing with analyzing the graph of the rational function. The first part of this says, what is the domain? So whenever it's asking about the domain, you set your denominator equal to 0 and find out about the vertical asymptote and the holes. Okay, so in this case, you have x squared minus 4 equals 0. And so x is plus and minus 2. Bless you. So the domain would be everything except for that, and so that's A. The equation of the vertical asymptote, in this case, your numerator is just x, and so your vertical asymptotes would be the plus and minus 2. So you can put plus and minus 2 like that, or you could say negative 2 comma 2, or vice versa, 2 comma negative 2. Okay, then the next part is about the horizontal or oblique. On this one, it would not have an oblique because the denominator's bigger. In fact, in this case, this would be proper. And so that'd be y equals 0 for your horizontal asymptote. You don't really have to circle horizontal, but because anytime it's proper, it's going to be 0. In other words, if you ignore the 4 part, it's just x over x squared. So the denominator's degree is larger. And so then it'd be y equals 0. And then we can pick which graph, bless you. We have x over x squared minus 4. X divided by x squared minus 4. It looks like this. So that's the C graph. And again, if you wanted to, you could change your window to be exactly what theirs was, like negative 4 to 4. That's why this part is like so long, because this goes to negative 10 and so forth. Also, just like I said on Friday, if you can pick the right graph, then it should also help you for your vertical asymptote and for your domain. Okay? Because if you pick the right graph, you can see there are 2 vertical asymptotes. And if that's negative 4, you can kind of figure out that'd be negative 2 and 2. And so that would be that part. And also the y equals 0 would be the horizontal line right there. So it's y equals 0 for your horizontal asymptote. So whenever you have multiple parts, if you look at your graph, you should be able to check your answer. Any questions? Okay. Next, number 11. Find the vertical, horizontal, and oblique asymptotes, if any, for this. And so what we're going to do is set our denominator equal to 0. X to the 14th minus 16 equals 0. There are a couple of different ways to go about this. I'm about to take the 4th root of 16. I believe it's 2. 16 up arrow. Y'all be kind to each other. It is 2. Now let's be careful about that, because we might have a plus and minus. What I really meant to do was I was going to say x to the 4th minus 16 equals 0, so then let's do x squared squared minus 4 squared. Wait, what am I? I think I'm just doing it wrong. Okay, so x squared minus 4, x squared plus 4. There we go. And then you can break down this into x minus 2, x plus 2, and then x squared plus 4. There we go. So that's what your denominator is. And you can see that there's going to be a positive and negative. So when I took the fourth root, I should have done plus and minus for that. Also, we know on this one that since the denominator's degree is greater, this is another one that's proper, and so it's going to be 0. And this has no oblique.
How do you know it has no oblique?
Because it's not x to the fourth over x cubed. So for the oblique, it's only if the degree of the numerator is 1 greater than the denominator. If it's 2 greater, then it'd be a parabolic asymptote, like if it's x to the fourth over x squared. And so you would still end up saying no oblique in that case.
So it's like only one.
It's so large.
I can't see that.
Can you calm down?
Oh, the other way? Okay, so basically the oblique asymptote would only happen if the degree of the numerator is 1 greater than the denominator. For example, like if it were x to the fourth minus 16 over x cubed, which is like inverted from what we actually have. Okay, so in this case, there's no oblique asymptote. So you would only have an oblique asymptote if it's 1 greater in the numerator. Any questions about that? Okay, number 12. Find your vertical, horizontal, and oblique asymptotes. So again, what we do is set our denominator equal to 0. So x to the squared, x squared or x to the second power minus x equals 0. And we ought to factor out x. So we get x is 0 and x is 1. Now, before I just write that down here, we need to look at our numerator. Okay, so this part was the denominator. If we set our numerator equal to 0, you'd have x to the fourth minus 1, which is really x squared plus 1, x squared minus 1. And then factoring that, you go with x plus 1, x minus 1. Okay, the reason why I'm doing this is, remember in our problems we wanted to get it in simplest terms. And so the simplest term would be like x squared plus 1, x plus 1, x minus 1 over x times x minus 1. So this is the simplest form of that. And what you notice is that these that I circled cancel, and so that means there would be a hole at x equal 1. There's a hole at x equal 1, not a vertical asymptote. And so because of that, the only vertical asymptote would be at 0. And we can verify that with a graph. So we've got x to the fourth minus 1 over x squared minus x. And there's your vertical asymptote at 0. And there's not a horizontal asymptote. And there's not an oblique either. There would be a parabolic. So these two answers are no. So there.
You know there's no horizontal or oblique?
Well, it doesn't look like it. And basically, if it were proper, it'd be 1 degree greater in the denominator, or 2 degrees greater in the denominator. The oblique would be if it's 1 degree greater in the numerator. So again, it's just a no-no for that. No horizontal, no oblique.
Can you show me the graph this week?
Yeah, right there. So there's no place where it's like a horizontal asymptote.
So if you just graph it, you can mostly find your answers from the graph.
As long as you're accurate, because sometimes it's like at a half or different numbers. Yeah. Yeah. Okay, good. Yes, you have a question? It's not like mutually exclusive on the vertical asymptote. It is kind of like mutually exclusive on these two. It's like if you might have none on both because you have parabolic. It's like really each question is independent. Yeah, you just need to look at every question. If it were like, if I changed the question to say x cubed, okay, then there would be an oblique, but there's still not a horizontal. Right. Let me pause this for a moment. Okay, so we've finished that one now. Now in 13, analyze the graph of the function. So again, for our domain, it's the same type thing as we said before. Set your denominator equal to 0. So x is 0, x plus 20 equals 0, so that's negative 20. So we get 0 and negative 20. This 3 here, or negative 3, I mean, is to throw you off because that has to do with the numerator, not the denominator. So that's going to be 0 and negative 20. Again, if you want to graph it to double check your work, you can. So we have x plus 3 and you have x times x plus 20. Just as a quick reminder before I press enter, when you have like x times x plus 20, you either need x dot x plus 20 or you need x and then x plus 20. Because if not, it's going to give you an error that says cannot accept change.
Oh.
Okay? So, do you want me to... Well, I know I've seen that error before if you don't do that. So, it converted it to the dot. And so, that's going to be what we want. For negative 20, we can double check that in the table. There was your 0 undefined. And there's your negative 20 undefined. Okay, so then your vertical asymptotes are going to be at that exact same spot. So this would be 0, negative 20. We probably ought to expand this left side to like negative 30. Okay, it's not letting me change that right there. So what I do instead is I go to my window, settings, and let's just make this negative 30 for now. And then you can see that your negative 20 was a vertical asymptote and 0 was. Okay. The horizontal would be at 0. So we've got y equals 0. Again, if you want to think of it, it's because of x over x squared, which is proper. And let's see. It looks like all these are showing from negative 24 to 4. Bless you. So if we go from negative 24 to 4, and then we want these to be like negative 4 to 4. Let's see. Negative 4 to 4. Then we can see the graph. It's going to match the B graph because it's going down first, and then it's like this, and then another one kind of like that on top. So that's B.
You know what they're having trouble with is finding the horizontal or vertical asymptote?
Okay, so the horizontal is it's easy if you know that the denominator's degree is greater. And if it's x times x, then that's why it's x squared. So that's proper and should be 0. So anytime it's
degree is bigger than the numerator,
it's 0. Right. And you can also check that on the graph where it's like that. Now just watch out if it ends up being 1 or negative 1, but you should see that in the equation. Okay?
What if the numerator is bigger than the denominator?
Then it'd be oblique.
Okay.
Yeah. And the case that we haven't talked about today, but we did on Friday, was what if it were this situation? Let me go to tab. What if it were x squared plus 3 over x times x plus 20? Then your degree of your numerator would match the degree of the denominator. And so you do your ratio, and so you get 1. X squared over x squared would be 1. So watch this just shift up just a little bit. Okay, so I would have to rearrange or readjust this window. But this is going to have a horizontal asymptote at 1. There's 0.5, and so like 1 would be like right there. Okay, so
There's no oblique or horizontal.
well, it's the same thing we've been talking about. You have to look at the graph on the question. In this case, we have our vertical, and we had 0. According to this picture, there'd be no oblique, because oblique means slanted, either up or down like that, positive or negative slope. Yeah. Again, if we go back to number 10, based on this graph, there's no oblique. There's just a horizontal. And you don't have to like cross out oblique and circle horizontal, but that's all that is. So, okay, good. Just 2 more. Number 14. Answer the following questions for this. So the way we did this before on the homework is to get a common denominator. And it's going to be of x cubed. And so we're going to have basically x to the 4th plus 6 over x cubed. So that's because if you want to write this extra step, you have your x already, and you're multiplying by x cubed over x cubed, which is equivalent to 1, plus 6 over x cubed. And so x times x cubed would be x to the 4th, and then plus 6, and then over x cubed. So in this case, your domain would be all reals except for 0, because again, it's based on your denominator, not your numerator. And for the vertical asymptote, it'd be the same thing. I think. Oh, let me double check that real quick. And graph it to be sure. So if we have x to the 4th plus 6 over x. Okay, let's go to the table. Okay, undefined right there. So it looks like we need to do zoom fit on this one. Menu, window, A. Okay. So zoom fit. Yeah, so 0 is your vertical asymptote. And then for the horizontal or oblique, we need to do our... Wait. I just noticed that I just put x there, and I should have put x cubed. Yeah, let me fix that real quick. X up arrow 3. Okay, there we go. So that matches what I was looking for. It's probably why it wasn't visible earlier. Let me go back to a standard window. 5. Okay, there we go. So we have our vertical asymptote at 0, and then this is going to be our slant asymptote. So to get that, we do our division. So we have x to the 4th plus 0x cubed plus 0x squared plus 0x plus 6 divided by x cubed. And so we just get x, then all these are 0, and then you end up with a remainder of 6. So this is just going to be y equal x. Yeah, you can. Yeah, y equal x, and it's right there, that red one. Yep. Okay. And based on the graph, it's A. So again, if you look at these graphs, all of these have oblique asymptotes. And then you just pick the right one. Any questions?
Can you move it up this time?
To this way?
Yeah.
Okay.
I'm good now.
Okay. Okay, then our last one, analyze the graph of the function. Okay, so this one we... let's graph it and see. What I'm going to do is set each term equal to 0 and find how we can factor this a little bit better. I think that'd be easiest. So let's set our denominator equal to 0. Okay, so this, go to our table. Well, between 1 and 2. So the table isn't going to help us completely. Also, you can notice some of these are fractions. So what we probably should have done instead was go to 0 the graph, and from here to there. Whoops. Whoops. Come on now. Menu, analyze, 0 the graph, from here to here. We get 1.16 repeat. 1.16 repeat. Now I notice the last number is 9, but that just might be a rounding type error. So if I go to the calculate screen, 7 divided by 6, control enter, that's actually what we want. So this is equivalent to 7.6. And again, all of these have 7.6. And then, okay, this is from the denominator equal to 0. The other one is right there, probably at a whole number 6, because all these have whole numbers. So let's just go to our table for that, to 6, and it is 0. At 6, it's 0. So that's going to be A. I mean, why did I say A? I'm pointing at this one. 7, 6, and 6. So that's C. Seven, 6, and 6. Then for our overall function, we have 54x squared minus 15x minus 56. Oh, I meant to put a divide by sign right there. Divide by there. Okay, so that's our overall function. We probably ought to change our window to be the settings here. Now these are like the negative 12 to 12 for both of them, and these are negative 24 to 24. So I'm going to choose the bigger window, which would be the negative 24 to 24 for both, just to compare it. Okay. So that matches the D graph. Okay, so for our vertical asymptote, let's see, 7, 6, and 6. What I want to do is set my numerator equal to 0 and see if we end up canceling the 7, 6. 54x squared minus 15x minus 56. Okay, so that looks like this. Analyze, 0 the graph. It's asking which graph, so I have to click the red graph in this case. Okay, there's the 0.8 repeat. When our numerator is 0, I get 0.8 repeat, which is 8/9. Oh, there's a negative sign in front of it. So the negative 8/9. If we need to, we can grab this and move it. There you can see the negative sign. And then, yeah, bless you. The other one, if we go on this graph, and it's from here to here, that's the 1.16 repeat, which was 7, 6. So what that tells me is this could be x plus 8/9 times x minus 7/6 over x minus 6, x minus 7/6. Okay, and then these cancel out, and so there'd be a hole in the graph at positive 7, 6. And so there's only one vertical asymptote, and it's at 6. There's only one vertical asymptote, it's at 6. So again, the possible vertical asymptotes would have been 7, 6, or 6, because that's where the denominator is equal to 0. But in this case, you only have one vertical asymptote, and it's at 6. Any questions on that part? Okay, then for the horizontal or oblique, all we do is take our greatest term on that, so we can basically cover up this. We've got 54x squared, divided by 6x squared, since the degrees match. On a lot of the others, it was either proper or not. In this case, the degrees match, so you use your ratio. So 54 divided by 6 would be 9. And so 9 is your answer. And you can't really just count it, but if you check on your graph, let's go to this again. Tab. And change this denominator function to just be 9. That's your horizontal asymptote. Okay, so see that red one? That's your horizontal asymptote, and it's at 9. Okay, any other questions on 15? Okay, 16. This one, the domain of this, it's basically telling you it's either going to be with 10 or negative 10 and negative 11 or 11 and possibly 0. So let's look at this. We have x squared divided by x squared plus x minus 110. I know I'm going to have to adjust my window, but it looks like 10 is going to be one of them and negative 11 the other. Based on this is negative 19 to 7, let's change that to our settings. Negative 19 to 17. Negative 19 to 17. And same thing for the y's. Negative 19 to 17. Okay, so there we go. And at 0, it was 0. Just notice that. At negative 10, it's negative 5, but at negative 11, it's undefined. So it's undefined at negative 11 and positive 10. Right there. So those are your two vertical asymptotes, and so that's going to be A. And so there's your 10 and negative 11. For your horizontal asymptote on this one, you do x squared divided by x squared, and so you get 1. And that's the D graph. Then the last part, well, there is a 17 and 18, so I guess let's finish this up tomorrow, and test will be Wednesday.
Can you go back over 3 seconds?
Yeah, sure. I'm just going to stop recording.